The number of brightness levels recorded in the data and the images that we work with in PixInsight, they generally exceed the number of brightness levels that we can display on our computer monitors at any one time. Usually our data has many, many more discrete brightness levels than we can display. So we have to choose or map those brightness levels in a particular way so that they are represented as something useful to us when we're working with the data in the program. Now we can not only do what I'm describing, which is just to display the data on the screen in some way, but of course we can also permanently adjust or modify the data in the images so that anytime we open it up again, it'll be displaying in some different way because we've actually changed the image. To begin with, then, you'll see that I have an image on the screen that I would argue is not a very useful representation of this. It happens to be a nebula. Now, you don't even see the nebula there. But by manipulating how we map the data, how we display those brightness levels in this image, suddenly this becomes a much more interesting thing to look at. And I will demonstrate that. We're going to look at two connected tools. We'll look at the ScreenTransferFunction utility as well as the HistogramTransformation tool. So those two actually, not only is the explanation concerning these things very similar because they speak the same language and they have similar parameters, but they are also intimately connected in the way in which you typically use them in PixInsight. To begin with, though, I'm going to start by giving an explanation that is of the kind that I typically do so that the language that I use will be consistent as I explain everything that I want going forward. What I'd like to show first is the idea of a histogram. You are already familiar with the idea that images have brightnesses for every pixel. There's a value recorded at every pixel. And what we can do is graph the number of pixels in our entire image, or in some fraction of the image, that are at a particular brightness. So that is what a histogram is. It is that graph, the frequency of brightness levels in the image. I don't even have it annotated in a specific way here. This is a very general way of indicating this graph where the horizontal axis represents the brightness levels, the vertical axis has the frequency. And this is a standard representation. It is what you will find in several places in PixInsight. It has this kind of generalized histogram-like graph. But the language that I want to use is specific to this kind of representation. So this graph may actually represent a typical image, though maybe somewhat exaggerated, in the sense that whenever we look at astronomical images, typically there's a lot of dark sky. I mean, there's bright stars, there might be a galaxy, nebula, but mostly dark stuff, not very bright stuff. There may be bright stars in the field, and the bright stars might be represented by these, this little bit over here, these pixels. There aren't as many pixels that are up at the bright region, so you can imagine that the bottom axis goes from 0 to whatever the value is. That's the full range of your detector. So this would be the upper end of this detector's range, whatever it is. We'll talk about the specific numbers in a moment. And then we don't have a whole lot in the middle, and then obviously we get lots and lots more until you get to the sky, down near the left side. And then finally, there is generally some gap between where the data kind of begins and ends over here on the left side, and that's due to another characteristic that's actually very important to consider. So the right side of this graph and the left side of this graph, I say, have a special name because the very right side, the full to the right, is going to be a saturated value, and fully to the left for the data, again I'm talking about just the data, would be the very smallest values that are recorded, potentially 0 or something like that. But it might not actually record 0. For example, if you have a camera that has a bias level, then it'll start at some offset. And this could represent a bias due to the camera, but it could represent a bias due to something else. In this case, it would be the sky itself. So if we're going to map these values onto the screen, because if this does represent a range that's more than 256 grayscales, 256 brightness levels, which is what a computer monitor gives us, if we have a 16-bit camera would have 65,000 brightness levels, we have to choose how to map that onto on our monitors. So you can imagine that we could use this as a mapping scheme. We take the full range and we just say, okay, that range of 0 to 65,000 for my specific CCD camera, we're now going to map those values against what the screen shows, which is 0 to 255. That's 256 grayscales. Where anything over here is going to be displayed as white, things here in the middle will be gray, and anything on the left side will be black. So as far as a screen representation, often called a screen mapping or a screen stretch, the left side, the leftmost part of this histogram, we're going to call the black point, at least where we choose that value to be, to begin where our analysis, and the white point is going to be the furthest to the right. That's where we're mapping any values that are at that point will be absolutely white, and anything that might be above that point would be white, and anything that might be below the black point, that is further to the left, will be black on the screen. So these carets define a point of whiteness, the white point, and blackness. Now if we were to show an image that looks as I have it mapped here on the screen, it would not be exciting. It's going to look very much like what I have here. And probably this is even worse, but let's look again. We have very few things that are white. We do have some whitish things, which are going to be the bright stars. We can certainly see that in our, and again, this is just typical. This is not specific to this image. But we see that here. We have some bright stars. Now, we don't have very much in grayness. I mean, I just don't see very many gray things. And there aren't very many gray things here. But there are many things that are just barely more than black or basically black. And that's kind of what this representation currently looks like. So what we would like to do is map this in such a way that it is more useful. It is a more useful thing to look at. So what we can do is we can change where that white point is. So if the range of our data goes from 0 to 65,000, and we move our white point, that is the mapping on the screen, we say, okay, everything that might be here, if this was 65,000, then this value looks like, I don't know, 15,000 or something. That would be here, right? So every value from 15,000 and above will be displayed as white on the screen. And everything then above that 15,000 is going to be what's called white clipped, because every value of the data is going to look white on the, absolutely white on the screen. And again, keep in mind, this is just a mapping. We're taking this data and displaying it on the screen in a particular way. We are not actually changing these numbers. So it is just a screen stretch. It is a screen mapping. Likewise, if we were to raise this black point, we're going to show that any data here at this point and to the left will be black on the screen. Well, that could include the sky, but if you were to bring this right up to this edge, you can make the sky dark, and then all the data will have the grayscales until you get to whatever point that you determine is the white point. So this manipulation in PixInsight is called the ScreenTransferFunction, and it has a tool that looks very much like what I am demonstrating here on the screen as far as manipulating the black point, the white point. However, there is generally also, let me just back up here, most of the tools in PixInsight and other programs, Photoshop and so on, they also give you a midpoint value. And we'll discuss the midpoint and how that works in more detail later. For the moment, recognize that by manipulating a midpoint, if you have the option to do so, is going to display the image in what is called a nonlinear way. And as part of this set of sections that I'll be talking about, the histogram, the ScreenTransferFunction, and the histogram transformation tool, we will get into this whole idea of linear and nonlinear data. So it is a nonlinear thing to either display or permanently change data when you start manipulating where that midpoint value is, if it is not exactly halfway between your white and black points. Let's go into PixInsight and see how all of this comes together. Here is a picture of a nebula, though I would argue it's not a great representation of the nebula, because as it is being represented on the screen at the moment, we can't easily make a decision as to what to do in terms of processing. The data is not being shown in such a way that it's either attractive or useful. So we need to brighten the image to help us out. That is on the screen. We're not going to change the data, just how it's displayed. And we'll use the ScreenTransferFunction to do it. So this is the utility, and I load it from my favorites in my Process Explorer. However, if there are many other tools that you like to have at your fingertips, you can always put them up here in the toolbar. Do that by going under View, Toolbars, and then you can reveal or hide any of these tools. And one of the tools is the ScreenTransferFunction. That's this section over here. So these are some of the controls for this utility. Now, in order to get the utility to work properly, let me reset it from scratch here. You want to edit it, and what we're going to edit should look very familiar to you, at least from the previous screen or slide, I hope, which is that this tool has carets in it. And these are the carets that we're going to slide around. It has the black point, which is the leftmost caret. It has a white point, the rightmost caret, and then a midpoint, which we're not going to touch. But just recognize then that when things are being displayed in a linear way, that this midpoint should be halfway between. It should be a midpoint between the white and black point. If that's not true, then you are displaying the image in a nonlinear way, which is just fine. But for the moment, I want to demonstrate how this works. I'm going to keep things kind of linear. The way the tool works, however, is you need to associate the tool with an image. Right now, there are controls for this tool, and one of the controls is to edit, that is to move around these carets, the white point and the black points, and so on. But if I move them around right now, nothing happens. Even though I've clicked on this image and I'm moving these things around, we don't see any changes. And that's because it isn't being associated with an image until we track the view, that is, track the image that we're interested in. So you've got to hit the check there. And by doing so, you'll find that we are able to track in all of the channels that are part of the image or part of the view that we're using. Now this particular image is a single, though it's a red image, it's a single monochrome image. It's not a color image. And so we only have one channel, the brightness channel available, the K channel available to us. You'll see that the RGB, or in this case the GB, and the luminance channel, which is specific to a luminance image, they are unavailable to us. So the only channel we're going to be operating on or doing anything with is the uppermost channel here, the brightness channel. Now when we have this checked or selected, now we can click with the mouse and slide things around, and the image will change accordingly based on what we're doing. I am making things brighter by changing where my white point value is, and I'll discuss that in just a moment. Notice, however, that everything's going to get kind of squished up here very, very quickly on the left side, so we'll need to zoom in to enable us to make some fine adjustments to what we want to do. However, if you ever get lost or unhappy with what you're doing, there is a way to get lost. I'll demonstrate in a moment. But if you're unhappy with what you're doing, you can always hit the reset button and just set it right back to the beginning, where you have the white point is on the right, black point is on the left. So you're looking at the full range of whatever the image presents, and the midpoint is in the middle. So just use judiciously the reset if you need to, if you get lost. Now here's how you can get lost. I'm going to lower my white point. Notice how the value of the white point of this caret is being shown. So this says that that value, currently it's at 0.47619, that value in the data is going to be represented as white on the screen, and any value in the data that is above this thing is also going to be displayed as white on the screen. So the white point is the lowest data point, that the smallest number data point that's going to be displayed as white. Everything above that value will also be white. So the idea that everything above this value in the data, that's called white clipping. So you'll see some of the tools talk about clipping for the upper end and the lower end, or the white and the black, or the shadows, or whatever. That's what they're talking about. They're talking about from the white point either above or beneath, if it's the black point, clipping those values, at least as far as the screen is concerned, or maybe as a real value where you're modifying the data itself. Here, I just want to stress this, we're not modifying any values of the data. It's just how it's being mapped to the screen in terms of an 8-bit representation, grayscale values that go from 0 to 255. So you can imagine this range, whatever I've chosen here, this is where 0 to 255 is going to be represented, and then everything above is 255, 255, 255, 255, and so on. However, as I continue to lower my white point, watch what happens on the screen. Lots of things become easier to see because now I'm sampling only this region for all of my grayscales. That makes fainter things in the data appear mapped as bright things on the screen, or brighter things on the screen. Now it's really tough to manipulate these arrows at this point. So we can and should zoom in. Just hit the plus. You can hit the plus anywhere you'd like here, and you'll be zooming in. But notice that depending upon where you click, if I click to the right, it expands everything to the right of a caret. If you click between two carets, it'll zoom in from that position. Now we're not changing the relative positions between the carets. So I am clicking to the right here, and I can make my little caret go away. Well, where did it go? It's way over on the left. So I have now an expanded this channel, but everything is over to the left. So we can pan by taking a little hand tool here, and I can slide things, and there's my white point again. And then I can slide things more, and there's my midpoint, and slide things again. Oops, sorry, I'm trying to slide. I don't usually slide around, but eventually we'll reach there's the black point on the left side. So these should be equidistant from one another. That's a big clue. Unfortunately, when you zoom in and you just see one caret, you may not know which caret you're looking at. Now if you click on the actual caret itself, you may be able to figure out the value that you're at, and that can be useful. So that'll tell you at least, some indication of where you are. Let's mess around with this. This is our black point. Let me zoom out and be sure you see what I'm talking about. Here they are. They're all now on the screen. We have the white point, the midpoint, the black point. We can zoom in and out, and we can move around, and we don't see things. But okay, first let's raise this a little more so it'll be obvious. So now I've raised my white point. The black point, if I wanted to make an adjustment, I can now raise this, and this will make things appear darker. That is, any value at this point and below will be exactly black on the screen. But let's use the white point for a moment. Let's just be sure that that really, really makes sense. So the white point right now is at 0.008. So that number, and any number higher than 0.008, should be white on the screen. Well, is it true? If you recall from the readout section, I should now be able to, because I've set up the program with this cursor, I can click on the screen and get a readout of any of these pixels I want. And the readout for this region, even though it's nebula, now keep in mind it's not actually saturated. That nebula in terms of an actual value is very small. But any value that I roll over here that's white should be bigger than 0.008, my white point. And lo and behold it is. Look, this one where I happen to be right now is 0.009, which is larger than 0.008. This is also 0.009. So everything makes sense. All of these values that are white on the screen are larger than the white point. Well, that should be pretty obvious. And the same thing would be true for the black point. If we raise this black point, it means that anything that I find is truly black on the screen will be equal to this value and some other value smaller than it in the data, but being represented as black on the screen. This is useful, maybe not in this example, but if we have a picture with galaxies and stars and we want the sky not to look gray but dark, we of course can raise the black level, and that'll increase the contrast, making the sky darker. And almost without skipping a beat, I need to very quickly mention something else. These tools over on the right, these first three here, this specifies a black point, a midtones, and then a white point. Now it calls it a readout. Well, I was reading out here without clicking on those at all. I've automatically had my cursor reading out. So I would say it's not even a readout per se, because it's being used to set. I would say it is a setting of the black point, of the midtones, and of the white point, because when you click these and then you click on the image, wherever you're clicking defines that thing as a black point or a white point or something. So if I wanted, let's reset here. I don't know, I'll reset. If I reset and then I click on the white point, and then I come over to the image and I click somewhere here in the image, it's going to define wherever I click and release to be my new white point. Now notice what happened here. My little white, I'm going to show that to you again. My little arrow went from all the way to the right and it went all the way squished into this little region. It's almost like it disappeared. Let's see that again. It was like magic. So here I am. I have my white point setter selected here, and I click on the screen here and see where it went. See, it's setting it to that position. Now by doing it, that can throw you for a loop. You might think, what in the world just happened to all my carrots? It's because you might have one of these things selected. I would recommend be sure these are off unless you know this is the thing that you want to do. I believe that it really should update at this point, but it doesn't until you adjust one of these carrots, and then it'll update. Once you go over and click on one of the carrots, then it will truly assign the mapping of where you are within this region. You know, I didn't mention this either. This is kind of an abstract tool. It doesn't have the histogram graph here. It just shows this range where we're playing with where the white point and black point is with regards to the data that's being represented within our picture itself. So I mean, I just hope that that's clear, that this is kind of this abstract tool of white point, black point. But we do get the values of the data because as we click and hold, we can see what these values are. Okay, let me show that to you again. I don't want to mess with the midpoint because that's a non-linear thing. Let's keep it linear here. Let's say that we wanted our white point to be something like a medium bright star. And I don't know if this will actually work, but let's try. If I click on one of these stars, am I still, yeah, see, I'm still all squished over here. Let's actually put it right on a star. Let's see if it makes a difference. If I put it right, it's hard for me to do. See, as I put it right on the star, do you see how the white point moves a little bit to the right? That's because these are bright pixels. It's hard though. There. And then of course if I click here, it's going to make the image look a little darker because now I'm saying the white point is, you know, somewhere in that region. So if I again click somewhere here for the nebula, do this, it'll get a very bright image. And if we wanted to do a black point, we can do the same thing. Let's say we wanted to be sure that this stuff is displayed as black. We go like this, probably have to click here. I don't know if I can. Should probably zoom in is what I should do. Let's zoom in, click on that caret, make sure it assigns it, and now it's assigned that value, whatever it was that I clicked on the screen, to be this caret position. And that's how you use these settings of the white point and the black point. And it also defines then a clipping point, if you will. So I'm going to keep these unselected. This is selected because I have a little whiteness around it, and this is unselected, selected, unselected. Now you can only have one of these selected, of course, at a time. But that's how that works. Whenever you're making adjustments using this tool, you can look at an image and know that the screen transfer function is in play or is being used to display the data, because you'll see the green line over in that view on one of these tabs, and that is showing you that this data is being somehow mapped or represented here on the screen by using the STF functionality. So when I reset it, notice what happens here. Even though I'm tracking, because I don't actually have a change, we haven't changed anything, the little green bar goes away. But once we start manipulating this, the little green bar comes and turns back on. So that's something to know. This will become important later whenever we are looking at an image that may be linear or non-linear. It's really important to know whether you're using the screen transfer function at the time or not. That's an easy way to distinguish. If the image, and I guess here's the point, if the image looked like some nice version of this to begin with, and it didn't look like a dark image, that might be a hint that the screen transfer function is in play here. But it could also mean it's a permanently stretched image, which means it'll look like that, but it won't have the screen transfer function bit, and that's the giveaway. Now there are other tools. We now know how to edit the white point and black point by sliding things around. We can zoom in and out as we wish. We can pan around when we are greater than the screen. Right now we're not greater than that area. Only when we become greater can we do our panning bit. Here we are, panning around. But there are also some tools over here for linking RGB channels. In a moment I'll combine these images so that we'll make an RGB image and then see how that works. Or actually I think I'll do it on there's a better example here, I'll do it on M27. There's also a way just to be able to get back to 1:1 if you wish for the zoom factor. And then there's the auto stretch. So now I'm going to pause because this is in a slightly different kind of topic here. There exists a way to automatically, algorithmically I should say, by a function, by math, choose what might be an optimal, or at least a set, kind of clipping and midtone value or level. So it's going to seem a little bit like magic. It's not. There's just some numbers you can input to begin with that are going to clip at a certain percentage by normalizing the data, by displaying data as values between 0 and 1. You can basically say that, well, you know what? I want to, everything that's less than, 0.1%, I want to be black. And above that, that's our clipping point, right? And then above that, we have some other values. And then we define a midpoint, and then we define that upper white point. Well, you can kind of mathematically take a good guess at that. And that's what pressing this button does. This is that famous auto stretch button. It does the math, and it determines a white point, a midtone, and a black point. Now notice what it does with the midtone here. No longer is it equally spaced. Look very closely here. My white point is way over on the right. My midtone is squished very close to the black point. Now this is a nonlinear representation, and in a little bit later on I'm going to demonstrate exactly what this means. But for the moment, recognize that what it means is that we are displaying more grayscales in the region that goes from the black point to the middle gray values of the data itself, we are, these points are not, these are a very small range in the data itself, but we're expanding that grayscale region so that we show lots of that very faint stuff in our data as gray stuff, and everything above it is just kind of, the rest of it is just kind of brightish things, I guess I'll say, going from the rest to the midpoint to the white point. That's why you get an image that looks like this. You can see all the nebulosity, but the stars are not blown out because all the other values in the data that are kind of star-like and a little bit less until you get way down to the faint stuff have all of those other whitish kind of bright gray grayscales. So that's how you get to this kind of representation. The auto stretch then is the way to make the image kind of look somewhat pretty. There's a wrench here where you get to control those parameters. And there are default parameters. When you reset this, it says that, oh geez, look at that. We have it reset to just linear, which is 0, the midpoint, and the upper. So by resetting, you're going to get back to your original reset. That's the same thing as pressing this little X, which is the same thing as pressing this reset, which resets all the channels. And that's the same thing as pressing the reset here. It's just resetting the white point, the black point, the midpoint. However, when you calculate, based on the function, you're going to get a response that looks like this. And every time you do press that button to calculate, you're going to get approximately the same answer. However, we can control that answer to some level by changing these parameters, especially, say, the midpoint here. If I change this to something that is, say, a smaller number, let's do 0.003, we will probably be more aggressive with that kind of brightening of the faint stuff. And the image becomes brighter. So what I just did is no different than as if I had just moved the little midpoint slider here. You can't see it because it's all squished in here. Let me zoom in. Here, I'll put it back to the position it was at. Watch the, I just did the auto. That's the position it was at, and then if we go to the little wrench and I put in the 0.03, watch the midpoint. It'll move, of course, to 0.03. And then if I put this tool here and I click, it's at 0.003. Sorry, I keep forgetting the extra 0.